Hello everybody, myself Seema Gondhalekar. I am going to teach you red black tree. Now objectives of this lecture is to understand need of red black tree, to study red black tree and to understand properties of red black tree. Now basically we'll see why we are using red black trees. Red black tree is a version of BST. Now you must be knowing what is BST. BST is binary search tree where the data which is at the left is lesser than the data which is at the right tree. So left tree is having lesser data and right tree is having greater data, and basically it is used for searching. When we want to search fast, we are using BST. The time required is average cases, order of logarithmic log of n. But when it is a skewed tree, the operations, all operations means search, insert, delete, max, min, whatever is required depend on height of a tree. If it is a skewed tree, means the data which is only greater data or only lesser data we are having, then it will be a skewed tree, maybe a left skewed or maybe a right skewed. Then at that time, the worst case, the operations required maybe become of order of n. So BST will not give you us a best search operations. So we have to require another type of tree. So we may take AVL tree or red black tree. Now red black tree is a balanced and height balanced tree, and it is always take searching on all operations required log of n time. Now n is the number of nodes in a tree. Again, AVL tree again gives us a time which is of logarithmic for all searching, inserting and deleting. So red black tree and AVL tree are almost, it is a balanced tree. But what is the difference? That is, AVL tree is a balanced BST but may cause more rotations during insertion and deletion. So it requires RR, LL, RL and LR rotations. When we are inserting one by one node, it may require multiple rotations. But red black tree does not require more rotations. So when the applications which involves more frequent insertion and deletion, at that time we require rotations. So when it requires frequent insertion and deletion, we use red black tree because it there are multiple rotations are not required than AVL tree. So what is basically red black tree? Red black tree is a binary search tree in which each node is colored with red or black. That is the first property. It is BST, so the data of left subtree has lesser value and the data at the right tree has a greater value than the parent value, and this is true for each node. It has some rules or properties. You can say balanced BST. Root is of the tree is always black. This is the first property. There are no two adjacent red nodes. Means a red node cannot have a red parent or red child of that node. Null child is considered as black. Then fourth property, the number of black nodes on every path from the root of each leaf is the same. That is called as black height. Now we'll see with examples of red black tree. I'll see one example. This is a red black tree. Over here, first property root is a black. Then we'll have red and black trees, black nodes over here. The null nodes or nil nodes are black only. There is no adjacent red nodes. Then the path length will say that is black height. Means over here we'll say one path to go to nil is this. Another path is this. Another path is this. Then this is another path and this is another path. Now over here for this path there are two black nodes. For this path there are two black nodes. For this path there are two black nodes. Now for this path again there are two black nodes. So this is called as black length and this is 2 for each path. So this is getting all the properties. So this is red black tree. Now I'll check some other trees which are red black tree or not. Now we'll see first tree. Now first property, that is root is black. Then though no adjacent nodes red. Then over here we'll check black length. That is from this we'll take this path 2 black nodes. from here there are 2, from this path there are 2 black nodes, but over here for this only one black node is over here, so it is violating that property, black length property. Now I'll check this. This is having black length 2, black length 2, black length 2, black length 2, no adjacent red nodes, black node is over here as a root node. So this is a red black tree. Now I'll see this. This is all nodes are black. So it can be a red black tree. There is no red red node over here, but all nodes can be a black nodes. So this is a red black tree. Now this is another only one node over here, but it is a red. So first property what it is, a root node should be a black node. It is violating. So this is not a red black tree. So these are the answer. First one is violating a property of black length. This is red black tree. This is also a red black tree which is having all black nodes. This is having one node, but it is violating, the root node should be black. We'll check another trees. Now this is having this property is not valid over here. That is 2 adjacent nodes should not be red. So this is not a red black tree. Now over here we'll check this path length is 2, path length is 2, path length is 2. So this is a red black tree and root is black and no adjacent red nodes over there. Now over here we'll check 20. This path is 2 path length. This is 2. This is 2 path length and no adjacent red nodes over here and root node is black. So this is also red black tree. Now over here we'll check. Now this path is having 3 black nodes and others are not having 3 black nodes. So this is not a red black tree and this is not red black tree. These 2 are red black tree. So we'll check. This is violating 4 black lengths. Now I'll check what is the node structure of red black tree. Now over here each and every node is having different parameters, that is color is main important over here and others are same as BST, that is key, left child, right child. This is optional. Parent is optional and we can consider this parent. Now operations which we can perform on red black tree is same as BST, that is search, then insert, delete, predecessor, successor, minimum, maximum. Now over here when we insert or delete, perform some operations. Now insert and deletion will violate the properties of red black tree. Now the properties you must be knowing, the root should be the root black node and no adjacent red node should be there. And when we insert a node in red black tree, we are inserting red node only and then we have to make some change that property which is violating by changing color or by rotation. So same as rotation, we require some rotation, but it is not frequent rotation is required. So rotation is same as right rotation and left rotation. So if we rotate like this, then P will be the root node, that is right rotation. Afterwards we'll get this, and if you want to see left rotation, it is like this. Now we rotate like this, Q will be the root node and P will get at left. Now when we want to color change, now it is like this, we can change like this, that is red to black, black to red. Okay. Now summary of this lecture is red black tree is balanced and height of red black tree is always order of log n, where n is the number of nodes in the tree. We can use AVL tree as a balanced BST, but many cause more rotation during the insertion and deletion. So the applications which involve many frequent insertion and deletion, we use red black tree than AVL tree. And it has some rules. Root of a tree always black. There are no adjacent nodes, that is red node cannot have red parent or red child. Null child is already considered as a black. Then the number of black nodes from every path from the root of each leaf is the same, that is called as black height. Thank you.